This is a K989 RWD conversion kit, but for reference, my car is 284131. The mechanical parts are more or less the same as the K-series. The name of this kit is BellX-M2. Bell because it uses a bell crank system, X because this is an experiment, and M2 because all screws used are M2. There are several advantages compared to modifying the stock bulkhead. Among them are longer suspension travel and a designed camber gain, so the wheels gain more negative camber as the spring compresses. The goal is to maximize tire traction during body roll, although I'm not sure if it makes a big difference on an RC this small. Still, I've designed it according to the principles. The suspension is also softer than the stock setup. A softer suspension with longer travel aims to maximize front tire traction so the car can steer better. As seen in the video, the front tire traction remains good when turning left and right, although in this video I set too much negative camber. The servo and electronics shown are stock from WLtoys 284131 with only a Desmicro V5 gyro added. Another advantage is that this kit offers flexible adjustments, camber, caster, toe, and even Ackerman. I also designed it to fit SG90, SG92R, or similar servos that are larger than the stock servo. There are actually several more advantages, but I won't go into them now. For this kit, I have tested it, and in my opinion the drifting feels better compared to modifying the stock bulkhead. Also, we don't need to damage the stock gearbox, so it can be kept intact. In slow motion, you can see the RC responds well and is quite obedient to steering corrections. The 3D print file can be downloaded for free on Thingiverse. This is the beta version, already usable for drifting, but I will still refine some details. I also shared the alpha version modification, which can use either a center steering system or a bell crank. Even though the alpha version can achieve a perfect 90-degree steering angle, I've tried it and it doesn't feel good for drifting. There are several reasons, but explaining them here would be too long. If you want to try the alpha version, there's an option I haven't tested yet that might actually work well for drifting. You can try installing a screw in the middle of the rear hole, inserted from the bottom. Install 2 M2 screws on top, or 1 lock nut with a washer. Then mount the center steering like this. Next, attach a ball head here to move the center steering. You will need a ball head with an M2 screw. The requirement is that you'll need to use a third-party transmitter, because if you use the stock transmitter, the steering direction will be reversed left to right. You'll also need to buy shorter third-party ball ends, or you can print this ball end. The result will look similar to this one's, only with the ball end positioned underneath. The reason I haven't tried the option I just suggested is because this time the focus is on a modification that doesn't require buying additional parts, and this has already worked in the beta release with the hanging bell crank system. Meanwhile, the alpha version seems to require extra parts to work well for drifting. In terms of flexibility though, the alpha version actually offers more possibilities. For example, it can also use a bell crank system, but with a slightly different mechanism. With the alpha version, the hinge can be mounted at the rear like this, or at the front. Maybe later, when I have time, I'll work on the alpha version again. Anyway, here you can insert the screw from the top without a nut. But for the middle and front screw holes, you need to insert screws from the bottom and use nuts again. In short, the version that has been proven to work well for drifting is the beta. I haven't had time to make a step-by-step assembly tutorial yet, but I definitely will once I get the chance. Still, if you look at the finished product, you should get the idea. Pay attention to the hinge. Make sure it moves smoothly. If not, use a 2mm drill bit to clean it up. For the lower arm, this section should move smoothly as the hinge, while the other side should not be drilled so it can hold the screw properly. All screws are M2, 2mm, just make sure the lengths are correct. Especially for the bell crank, make sure no screw heads stick out because they can jam the system. If you use the stock servo, also install the adapter. Just make sure not to install the front and back sides reversed. It only affects aesthetics, but better to keep it neat. Meanwhile, if you use an SG90 servo or similar, the ball head needs to be flipped as shown in the video, then mounted onto the servo arm. The reason it's flipped is so that the connecting rod doesn't hit the bell crank during movement. Also note that the clearance here is very tight with the deck, so make sure the ball head screw doesn't stick out or it will touch the deck. This is actually what made this mod quite time-consuming. At this scale, even a 0.5mm difference has a big impact. The The servo arm position is slightly angled, as you can see in the video. Don't set it perfectly straight, so that left and right steering movement stays balanced. The part names can be seen in the video, just pause it if you need to. This is the bottom view. For the ball head, I used the ones from the stock shocks. The connecting rod is also from the stock left-right steering link. For the M2 screw on the wheel hub, use a longer one so it also acts as a stopper. This prevents the wheel from turning too far into a steering lock position, which would stop the tire from returning to center. Anyway, for the C-hub bearings, install all the bearings from the front. Also adjust the screw tightness carefully. Not too tight so everything moves smoothly, but not too loose either. If you change the camber angle, you'll need to readjust the screw tightness on the upper arm so it's not wobbly but still moves freely. For the final version, it won't be much different from the beta version. The main addition will be a more precise suspension stiffness adjustment. Right now, to change spring stiffness, you still need to use spacers from the stock shocks. I also haven't had time to design the body posts yet. These two holes at the front are meant to hold the body posts. So if you don't have a 3D printer, I'd recommend waiting for the final version. But if you can't wait, you can try the beta release. Or even experiment with the alpha version if you like. If the file name contains alpha, that means it's the alpha version. For the lower arm, upper arm, C-hub, and other parts, they're the same or compatible with the beta version. My plan is to use a Porsche GT3 RS body. I think it will look awesome. The wheels are already quite close to the real ones. The body is from a Miniso toy produced by Rastar. Thanks for watching Quick Mix channel. I hope this video is useful to someone, inspires you, or at least gives you a new idea. See you in the next one.